Hello and thank you for joining us today for Understanding ESA. I'm Dave Grabowski. Today we're going to be talking a little bit about the federal government's recent Energy Independence and Security Act. With us today are John Malinowski, Senior Product Manager for AC Motors with Baldor Electric, Ted Clayton, Kaman Industrial Technologies Manager of Energy and Power Management Services, and Bruce Benkhart, Director of Industrial Programs with Applied Proactive Technologies. Bruce, let's start with you. Your firm works a lot with consumer-based and industrial-based customers, and I know you spent a lot of time studying this legislation and the long-term implications for end users. Can you give us just a brief overview of some of the ramifications and what it means to end users and why this legislation was enacted?
Sure, Dave. As a quick overview, ESA is merely the most recent in 20 years of federal energy efficiency legislation, which also includes EPAC 1992, EPAC 2005. It builds on those, increases the scope of product that's covered, addresses many other products besides motors, of course. So not only does it increase the scope, but it raises the energy efficiency bar on, in this case, electric motors.
Okay, and raises it in what way? What does that really mean to an end user?
Well, EPAC standards had set the limit at a certain point in the 1992. In 2005 it was raised, but merely raised again to the NEMA premium standard, but only for federal facilities. Now that's applied to all consumers. So the scope that it now increases, it takes what they call subtype 1, which is in fact the EPAC standard for NEMA premium for the 1 to 200 class motors. It also includes and bolts onto that more coverage, which is the 2 to 500 horsepower NEMA B class motors. And in addition, it starts to round up the other motors which were previously not covered by EPAC, which is they classify as subtype 2, which includes close coupled motors, 600 volt and less motors, vertical motors, and so forth.
Okay. And when does this legislation take effect?
It takes effect specifically on December 19th of this year.
Okay. All right. So it's coming out quickly.
Indeed.
John, is one of the leading manufacturers of electric motors in the world. Can you tell us a little bit about what the ramifications of that are for you as a manufacturer, and then in turn, how that's going to affect end users?
Sure. Well, this ESA Act is regulating the efficiency of electric motors that we can make as a motor manufacturer. It builds on the EPAC legislation of 1992, which was enacted in 97. That set certain efficiencies for 1 to 200 horsepower motors at NEMA MG1 Table 1211 energy efficient motors.
Okay.
The motors that were energy efficient in that 1 to 200 horse range in 97 now move up to the NEMA premium level, MG1 Table 1211. The motors that were not covered back in EPAC are now moving up to Table 1211, the old EPAC levels. That'll be the subtype 2 motors, the close coupled pump motors, the footless motors, design C motors, U-frame motors, all of those and a few others have to move up to 1211, as will 201 to 500 horsepower motors.
Okay. What about existing inventories? I mean, there are a lot of people, both your own inventories and our inventories as a distributor, and then of course, the stock rooms and the inventories that are there for end users. Are those now obsolete? Are those still able to be used?
Right. The law requires us to make the change over to the new motors on the 19th. So the existing inventory that we have as a manufacturer, that you have as a distributor, and that the end user has, can be utilized.
Okay.
No restriction.
What about cost implications? As people are upgrading, or as you're having to manufacture a higher standard of motor, what's that going to mean for the end user in terms of a cost increase?
To go from a lower efficiency motor to one with higher efficiency, we use more material, more electrical steel, more copper, more aluminum, more cost. What you would see on the difference between an energy efficient and a premium efficient motor might be an average of 20 or 30%. additional cost.
Okay. So are we talking about model number changes here? I mean, are people going to have to change their specifications, or is this just an upgrade to the existing motor, the existing manufactured motors?
For most cases, the model numbers are already in the system and customers are buying them. The non-compliant motors that are the ones being replaced by the premium, the non-compliant numbers will go away and be supplemented by the model number. In other words, a Super E motor is an EM3546T will replace an M3546T in the Baldor system.
And are there any concerns with a manufacturer's ability to comply with the new standards?
Baldor Electric is ready for the standards. We've been converting to this for the last 3 years.
You find that the manufacturers...
Well, you know, I think it may come into play for some of the import brands. You know, Baldor's in a position of leading the industry. They've been manufacturing a high efficiency motor for decades. They're in a good position to adopt what the legislation is asking. But I wonder if a number of the import products that may have only manufactured standard and EPAC level efficiencies, you know, we're not quite sure if they're prepared to make the investments to get into position to produce the NEMA premium levels.
Okay, so something to be aware of, obviously.
Yeah.
So, Ted, what about end users then? Are they going to have to reconfigure their systems as they're changing specifications, upgrading to the new standards?
You know, the biggest place for people to pay attention is on the speed of the driven load. The more efficient motor runs a little bit faster than EPAC, which ran a little bit faster than the older standard efficient products. The most significant case would be variable torque applications like fans and pumps. Centrifugal loads, if the speed increases, then the energy required to operate the load increases. And that may be not exactly what the market's expecting. They're thinking lower energy costs with higher efficiency product, but as it's applied, it's a consideration that needs to be looked at closely.
Okay. And you know, what about just reusing their old motors? Can they continue to get those rewound? Is that anything that's being controlled?
Yeah, that's a viable option. The legislation doesn't preclude people from making repairs and continuing to make repairs. But I think if people are paying attention to what's intended here, you know, it's about national security, it's about energy independence. There's an opportunity to lower the cost of operations for that end user if they'll follow the intent of the legislation.
Okay, great. And Bruce, what's your experience been along those lines? Are you finding that people are embracing this opportunity to upgrade, or has there been more reluctance, more resistance towards it?
Well, as John pointed out, the NEMA premium motor, now being the standard, has been around for quite some time. It's not new to the marketplace. Adoption, in our experience with our research in New York State for NYSERDA and our surveys, indicates that the adoption rate has not been as fast as we might have expected. And there are a variety of reasons. People do rewind motors. They're in certain circumstances, and there are cost savings to be had there. However, as those motors do ultimately fail, they'll have to be replaced with NEMA premium, which presents certain issues that have to be addressed. However, the energy savings can be profound. As John, of course, can point out, the first cost is minuscule, a few percentage of what the life cycle cost of the motor is. So it's money well spent, provided you're prepared to address the issues that higher speeds present.
Well, you know, certainly given the state of the economy and people's reluctance to take on what could be a 20, 25, 30% cost increase in some cases, you know, it's understandable that people would be hesitant to bite that off if they could avoid it. But isn't it important that they look beyond that, just the upfront costs, and understand what the total savings opportunity is? Ted, can you talk a little bit about that? I
think you've hit the proper perspective here. You know, this is an opportunity to improve their overall operations and take energy cost down. To put some numbers to it, on an annual basis, this change would offer hundreds of thousands of kilowatt-hour savings to a typical user. In dollars, it's tens of thousands of dollars of savings in the operating cost. And for those pursuing sustainability, you know, there's tens of tons of carbon emission equivalent benefit here too. So yes, it's a consideration to look at first cost, but it's a much more significant consideration to look at the operating cost.
And then how are you defining a typical user? I mean, you could be talking to a manufacturer that's a mom and pop shop on up to, you know, a large automotive manufacturer.
You know, it varies a little bit with their motor population, large motors and small motors. If people look closely, they'll actually find there's a greater opportunity for savings on smaller ratings in terms of percentage saved than there is on the high horsepower. So depending on their plant and the population, if they've got a lot of small motors, they may be thinking it's not very significant because they're small motors. That'd be actually not true. If they look at the numbers, there's a significant, more significant increase in efficiency on the lower horsepower ratings. And so then the next consideration, depending on their business and their plant operations, run hours. The more run hours involved, the higher the cost to operate the equipment and the greater the savings to be gained with this change.
And of course their rate, whatever their rate structure happens to be, kilowatt hour.
Yeah.
What are some of the other implications or benefits that are associated with upgrading to a higher standard of motor? John, can you talk a little bit about some
Sure.
of the...
I think we're looking at a motor that's more friendly to operate on an adjustable speed drive. The motor runs cooler. If it's an air-conditioned plant, that would reduce the heat load for the plant. It's got a smaller fan on it. It'll run quieter. Generally, they have better balance standards. They're just manufactured to closer tolerances than a normal motor.
So they're more reliable, essentially.
More reliable. We've got a longer warranty with premium motor. Baldor's warranty is 3 years. It's 5 years on our IEEE 841 model.
I think that's a key point for the market to gauge. That's really, to me, that's the confidence indicator. It's a better quality product, designed better, and yet, how do I know? Well, it's backed by a stronger warranty. So that should be the confidence factor for the market to recognize.
Good. Bruce, anything to add to that?
Well, indeed, that is, while we live in this world of energy efficiency, the facility manager's world, job one is keep the facility running and running smoothly with as little downtime as possible. Some of that sort of aversion to risk has played into the fact that many facilities do rewind motors that probably are vampires and really should be out of service and should be replaced. But in the interest of a known motor that's operated well over the years, they'll continue to rewind it. Sometimes even when the rewind costs exceed what it would be to replace it with a NEMA premium, perhaps again because of the aversion to changing a motor to a different speed and what the implications might be.
I think you've hit another key priority, though, Bruce. The standard efficient, oldest motor with the highest number of prior repairs is really where this
Indeed.
opportunity is most significant. So that's a great way to help prioritize the effort as well.
Mm-hmm. And it's a significant thing is getting ahead of this for facility people understand their motor population so that they can prioritize it, be prepared ahead of time for when a given motor fails, what will be the method of dealing with it. Does repair make sense from a fiscal standpoint, or does replacing it? If replacing it, then look, as Ted pointed out, to other opportunities besides just the motor. Looking at VFDs, looking at transmission issues where the greatest losses truly are. It's a great opportunity to improve the efficacy of the entire system.
Can you talk a little bit about the impact of coupling a motor with a VFD and how that might exponentially increase the savings?
Yeah, I think that it's another aspect to the topic that's not exactly brand new, but I think Bruce should agree the rate of adoption. It still tells us there's a significant opportunity. Mm-hmm. A lot of fixed speed equipment that's suitable to operate variable speed has yet to be upgraded. So it's running fixed speed. It may use throttling valves on pump systems or bypass loops. It may use outlet dampers on fan systems. Those mechanical flow controls, that's where the most substantial opportunity really is. The motor is a good contribution, but replacing those controls and going variable speed is 3, 4, maybe 5 times as significant.
John, yeah. I know you guys watch this very carefully and work closely with end users. Why do you think there is that reluctance, or there's that low adoption rate of coupling motors and drives?
I guess risk. There's a lot of wives' tales about drives are going to burn up motors. That may have been true many years ago, but the NEMA premium motors built today are inverter ready. They're capable of being operated from an inverter. They've got a lot of headroom for temperature rise. We know how to hook up motors, how to wire them so they last. The drives today are better than they have been in the past. When we think about using drives, we think about process control, adjusting all the flow of products so that they're optimized and they save even more energy. You shut things off when you don't need it running. I mean, the most efficient motor running is one that isn't running. It's not using any energy. So, you know, let's look at how we match flows up. If you've got a mixer that has 5 pumps going into a common slurry, you can change the ratios of that with drives and optimize it. So process control is something that fits into this as well.
Well, you know, given that this legislation is now here, and you know the availability of standard efficient motors is going to dry up over time, you know, everyone's going to have to deal with this sooner or later. What's your recommendation for the best way to approach that? Ted, why don't you start?
Well, you know, Bruce alluded to it earlier. I think it's to be prepared, plan out and prioritize your applications by the horsepower involved, the age of the equipment involved, the run hours, and yeah, if you have multiple plants, then yeah, energy costs are another way to prioritize. Where's the quickest returns? But that's the key piece, I think, is to look at your situation in advance and make a plan, make a strategy.
Bruce, your thoughts?
Well, in spite of the fact that ISA is motor-centric, as we've all discussed, the true opportunities here exist in looking at your facility as motor systems, all the way from the wall through a VFD to the motor to transmission, and really optimizing that. We see many situations where motors are oversized for the sake of a given motor failed, put more horsepower on it, and that'll overcome the issue. So there are many opportunities. So again, developing a plan and looking not just at the motor, but looking at, well, while I'm looking at it, let's look at the entire system. Yeah. What can we look at with potentially 30, 40% transmission losses that could be avoided? Looking at replacing the motor, putting in VFDs. There are upfront costs, but the savings are tremendous. Again, if I might, industrial facilities probably understand that their electricity use, 70–75% of which is entirely motors and motor systems. So it really is the point you have to direct your efforts towards.
John, anything to add?
Well, I'd say, you know, make a plan, have a policy on what motors you buy, what motors you repair, the repair-replace decision. At what point do you repair and replace, both by a horsepower and cost basis? When you buy new equipment, you know, be sure to specify what motors you need for those applications. Look at how many hours the motor runs. We've got software that can help you make these studies. There's a Baldor energy savings tool software that'll go through, and you put your inventory of motors on there, how many hours they run, and it'll calculate your energy cost and make suggestions and prioritize what motors you might use as replacements.
Okay, good.
And it goes as far as putting scenarios in there. What if I use a drive on this? What are my energy savings?
Terrific. Well, thank you all for being with us today. We appreciate your time, and thank you for joining us today. We hope you found our webcast helpful in helping you understand not only the implications, but also the opportunities associated with the new ESA legislation. If you have any follow-up questions that you'd like to address to any of our panelists, please feel free to contact them directly using the information on your screen now, or call 1-800-526-2626 to reach a command representative nearest you.